Mars, the red planet, a world that has captured our imagination for generations, glowing with a mysterious rusty hue. It hangs in our night sky like a rusty jewel, a beacon of curiosity for humanity. Even from millions of kilometers away, Mars calls to us, its presence unmistakable among the stars. For centuries, we've looked up and wondered. Ancient astronomers tracked its movements, weaving stories and myths about this wandering red light. Mars represents the next great frontier, the next step in our cosmic journey. It's a destination that challenges our technology, our courage, and our dreams. It's a world similar to ours, yet profoundly different, with mountains, valleys, and polar ice caps. Its landscapes are both alien and strangely familiar, inviting us to explore further. The dream of walking on its reddish soil drives our science and exploration spirit. Each rover's track and every grain of Martian dust brings us closer to that dream. The desire to go to Mars is about more than just planting a flag. It's about uniting nations, pushing the boundaries of what's possible, and inspiring generations to come. It's about answering the biggest questions. Are we alone? Could there be life, past or present, hidden beneath the Martian surface? Could life have started on another world? The evidence of ancient riverbeds and hints of water fuel our search for answers. Exploring Mars helps us understand our place in the cosmos. By studying its history, we learn more about Earth's own past and future. The journey to Mars is a journey to understand ourselves. It's a test of our ingenuity, resilience, and our longing to reach beyond the horizon. We imagine astronauts in spacesuits, taking that first historic step onto the ochre dust. That moment will mark a new chapter in human history. This vision fuels space missions worldwide. Engineers, scientists, and dreamers work tirelessly, turning science fiction into reality. By exploring what happens if you fall on Mars, we uncover what it takes for humans to become a multi-planetary species. Mars is not just a destination, it's a symbol of our endless curiosity and our drive to explore the unknown. Gravity. It's a force we rarely think about, yet it shapes every moment of our lives. The invisible force that keeps us grounded, holding us close to the surface of our planet and making everyday actions possible. On Earth, we're perfectly adapted to its pull, but when we set foot on Mars, everything changes. Mars, being smaller and less dense than Earth, has a much gentler gravitational pull. Its surface gravity is only a fraction of what we experience here. Imagine weighing 180 pounds on Earth. On Mars, you'd weigh about 68 pounds. That's less than half your Earth weight, a dramatic difference that would be immediately noticeable. Mars' gravity is only 38% of Earth's, making every movement feel lighter, slower, and almost dreamlike. You'd feel lighter, almost superhuman, able to leap higher and carry heavy equipment with surprising ease. On Earth, a good jump might get you 2 feet off the ground. On Mars, that same effort could send you soaring nearly 5 feet into the air. This newfound lightness would be exhilarating, but also disorienting, requiring a complete recalibration of movement and balance. Weak gravity changes everything: how fast you fall, how you land, and even how difficult it is to get back up after a stumble. While feeling light sounds fun, it presents real challenges for astronauts trying to work, move, and stay safe on the Martian surface. Our bodies are used to Earth's gravity. Mars requires adaptation, both physically and mentally, to avoid injury and perform daily tasks. Walking, running, and even standing must be relearned to avoid a clumsy, potentially dangerous tumble in this unfamiliar environment. The simple act of falling becomes a complex question on Mars, as the reduced gravity changes how your body reacts and recovers. Understanding Martian gravity isn't just about physics. It's a challenge that brings together science, engineering, and human adaptability, shaping the future of exploration on the red planet. Picture this. You're standing on the red, dusty plains of Mars, surrounded by a landscape that feels both alien and breathtakingly beautiful. You're an astronaut, momentarily distracted by the sheer scale of Olympus Mons, the tallest volcano in the solar system, its shadow stretching for miles. Lost in awe, your boot catches a jagged Martian rock, and suddenly you begin to fall forward, arms flailing in the thin, cold air. On Earth, a stumble like this would be over in a blink, a quick, jarring event. But here on Mars, everything seems to move in slow motion. Mars's gravity is only about 38% of Earth's, so you accelerate towards the ground much more slowly, almost as if you're floating. The fall feels strangely drawn out, giving you a surreal amount of time to process what's happening. You might even have time to think, "Uh-oh, I'm falling," and wonder how this will end. Instead of a rapid crash, your descent is almost graceful, a lazy drift toward the rusty soil below. On Earth, a fall from standing height takes about half a second. On Mars, it's closer to a full second, twice as long to brace yourself or to panic. But your spacesuit is bulky and stiff, making quick adjustments or last-minute saves nearly impossible. Every movement feels exaggerated and slow. Your center of gravity is higher, thanks to the bounding, springy steps you take in Mars's low gravity. It's a peculiar sensation, unlike anything on Earth. For a brief moment, you feel almost weightless, suspended above the surface, as if time itself has slowed down just for you. When you finally touch down, the impact is surprisingly soft, a firm bump rather than a painful thud, cushioned by the gentle pull of Martian gravity. The reduced force means you're far less likely to break a bone, even after a clumsy fall. But the real challenge begins when you try to get back up. The suit, the gravity, and the awkwardness all combine to make standing a slow, deliberate process. This slow-motion fall is a uniquely Martian experience, one that's both disorienting and oddly beautiful. On Mars, even a simple fall becomes an adventure, a reminder that here, gravity plays by different rules. Falling on Mars means falling inside a life-sustaining machine, your spacesuit. This suit provides oxygen, pressure, and protection from Mars extremes. But it's bulky, heavy, and restrictive. On Earth, a spacesuit weighs nearly 300 pounds. On Mars, about 114 pounds. Imagine wearing a padded snowsuit with a fishbowl helmet and stiff gloves. Every motion is a struggle. The suit fights against you. Bending requires effort, like bending a stiff balloon. The suit's bulkiness makes you less agile. On the ground, your range of motion is limited. The suit's joints allow only certain movements. The helmet restricts your view, and the backpack changes your center of gravity. The gloves make it hard to grip or push against the ground. Getting up becomes a complex problem. You're on the ground, red dust settled. You can't stay here. The mission must continue. On Earth, you'd push off the ground, but on Mars, it's nearly impossible. The suit's stiffness and gloves prevent simple maneuvers. Rolling over is hard. The backpack gets in the way. Getting up requires a special technique, practiced for hours in training. From your back, rock side to side to get onto your front. Push up with your arms, fighting the suit's pressure. Walk your hands back, trying to get a knee under you. It's slow, awkward, and exhausting. Every movement is a workout. Your heart rate climbs. The suit's cooling system works overtime. On Mars, a solo explorer who falls could be in a serious situation. The ability to stand up is a matter of survival. A fall on Mars might not hurt much on impact, but dangers are real. The primary concern is a breach in your spacesuit. The Martian surface is rocky. A tear or crack is critical. A breach means your air leaks into the thin Martian atmosphere. Alarms blare, warning of pressure drop. You'd have minutes or seconds before losing consciousness. Spacesuits have tough layers and patch kits for repairs. Beyond a suit breach, there's risk of damaging vital equipment. A hard fall could damage life support systems. Even intact, a broken radio or cooling system is dangerous. On Mars, your equipment is your lifeline. A simple fall opens a Pandora's box of potential dangers. Compare a fall on Earth to one on Mars. On Earth, gravity pulls you down fast. You hit the ground with a thud. Getting up is straightforward. Your muscles and brain are tuned for it. On Mars, gravity is weaker. You float downwards. The fall takes twice as long. The impact is a gentle bump. You're in a 300-pound suit on rocky soil. Getting up is a slow, calculated procedure. On Earth, you feel wind, hear impact, smell grass. On Mars, there's near silence. You hear your breathing and suits hum. Your world is confined to your visor view and glove feel. Space exploration challenges are in everyday actions. Walking, picking up a rock, or getting up must be re-engineered. Living on Mars requires unlearning Earth's physical intuition. It's adapting to new rules dictated by the cosmos. How do we prepare astronauts for Mars challenges? Space agencies simulate the Martian environment on Earth. The Neutral Buoyancy Lab, a giant pool, mimics low gravity. Astronauts practice moving, using tools, and recovering from falls. They repeat drills until procedures become second nature. Virtual reality systems simulate low gravity for dynamic practice. Training isn't just physical, it's about staying calm under pressure. Astronauts practice emergency scenarios like a suit leak. Mental conditioning is as important as physical strength. Engineers use training data to improve spacesuit design. They redesign suit joints for better flexibility. Preparation is everything. Training makes future missions safer. The first person to fall on Mars will get up because of Earth's training. Falling on Mars teaches profound lessons for space exploration. It's not just about rockets and habitats, it's about adapting to new environments. Mars's low gravity offers freedom but challenges balance and recovery. The spacesuit protects but hinders agility. These paradoxes push us to innovate and prepare. Every grand vision requires solving practical details first. Teamwork and robotics are crucial in space exploration. A fallen astronaut might need help from a crewmate or robot. Robots handle heavy tasks, freeing humans for discovery. Falling on Mars grounds our ambitions in reality. It forces respect for the new environment. Every challenge is an opportunity to learn and prepare. Understanding a fall is a step toward humans walking on Mars.